Okay, guys. A jar of jelly beans contains 50 red jelly beans, 45 yellow jelly beans, and 30 green jelly beans. Find the probability that both the first and second jelly bean drawn from the jar are red. Give your answer as a percent. And guys, just round it to the nearest whole percent. Okay? Now let me ask you something. Critical question. Are these events independent or are they dependent? Current?
They are independent.
They're not independent. They are dependent. And here's why. Because as soon as I choose the red jelly bean on the first one, it's no longer there for me to choose again on the second one. Okay? Now, what's the probability that I'm going to choose a red jelly bean on the first one? Arjun? 50 out of 125. Okay? Now, who can tell me what's the probability that I'm going to choose a red one when I choose again on the second try? Chris? 124. Because that first red one is out on the table. Okay? Now, these are the two probabilities for each of those events. I need to find out what it is, what their probability is as a percent. I can write this as a fraction, right? I can just multiply these two fractions. And Ben, will you tell me what 50 times 49 is? And Taro, will you tell me what 125 times 124 is? Okay? Ben says 2,450 for the numerator. And Taro, what'd you get in the denominator? 15,500. So that's what it is as a fraction. David, will you please change that to a decimal for me, please? With that trusty calculator. Remember, it's always the top divided by the bottom. And what do I get? 0.15806 4 5. I'm sorry, in the last? 16. Is that it? Okay. Now, how do I write this as a percent? Jemba? How do I write decimals as percents? Okay. Gordy? How do I do that, Ben? Move the decimal point over 2 places so that I get 15.8064516. And I want to round to the nearest percent, so I'm going to put my gate right here. And what do I get once I round it, please, Alexander? 16%. I look at this one, I don't care about those, and that goes up 1. So 16% is the answer there. Thank you, guys. You did a great job.